All right, good morning, everybody. So today we'll start. Actually, nag-start na pala tayo last meeting with module number 3. At least a peek on it. I think I introduced what the convolution operation looks like, right? Or the convolution operator looks like. However, as I mentioned before we started the recording, I made little changes to how we define the convolution is. Napaka-specific ng previous definition ng convolution na binigay ko. Just to follow the discussion from Siltanen, dun sa section or chapter 2 ni Siltanen. But I realized mas okay na ipakita sa inyo muna yung generic definition or yung mas general na definition ng convolutions because say if you'll be working on signal processing later, mas okay na nakita nyo yung more generic example. But before we proceed, any questions about homework number, anong homework number ba yun? Homework number 1? Or homework number 2 na ba yun? How is it going along? Patapos na ba or what? Ayaw nyo magkomento? I think I've just seen only one submission so far. Kailan nga ba yung deadline nun? Ngayon ba? Or tomorrow? I forgot.
Friday po, sir. Tomorrow po.
Tomorrow. Thank you, Lian. Yeah. Kakayanin ba tomorrow? Sana kasi nakailang extension na yun, ano? Pero parang isa pa lang yung nagpasa. So, nag-gradean ko na yung work nung nagpasa. Okay. And I think there's another one of you already working on it kasi dalawa na yung nakita kong entry dun sa Google Sheet. Again, before you submit or before actually before you write your final solutions, make sure na wala pang katulad yung noise vector na pinili nyo because mas gusto ko na yung unique vectors na ibibigay nyo. Anyway, nag-randomize naman kayo ng vector na ang relative size ay 1% dun sa right-hand side nung linear equation na nandun sa module number 2. So, there are infinitely many options for it. Pero para ma-experience nyo, isa-isa, right? So I hope you are using MathLab and nag-compute kayo or tiningnan nyo kung paano ko magagawa na 1% yung noise. It's a simple algebra para makita nyo na, okay, magpaparandomize ako kay MATLAB, halimbawa, rand of 3, 1. It will give you a random vector of 3 rows and 1 column. All right, so yung syntax na rand of 3, 1. Ang laman ng vector na yan, may tatlo siyang components arranged in rows. Tapos ang kanilang range ay from 0 to 1, random numbers from 0 to 1. So ibig sabihin, hindi tayo sure na ang size nito ay 1% ng original 1% ng original right-hand side. So how do you force the issue? Well, you can multiply it by a scaling constant. How does that scaling constant looks like para ma-force na 1% yung size ng noise vector? Well, you do the math. Okay, try to do the math kung paano siya pepersen because as we go along, pag nagsosolve tayo ng inverse problems, kailangan natin na i-consider yung noise vector because as I've mentioned last time, inverse problems are ill-posed by nature. So ibig sabihin, if you don't take into account yung noise vector or yung perturbation ng data dun sa inverse problem, your results might be meaningless. Because again, most probably, pag mayroon kang inverse problem, hindi satisfy sa H3. So the solution will not continuously depend on the data. Small perturbations in the data can give off very significant changes in the solution that you obtain. So lalo na kung nanggagaling sa physical measurements yung inyong right-hand side. So hindi nyo nakukuha yung actual right-hand side that is spelled out by the phenomenon, but you are getting some erroneous data, right? So the data plus the measurement error, yun yung sinusolve nyo na linear system. And if that small measurement error will cause huge changes in the actual solution, then hindi mo magagamit yung result mo na nakuha dun sa inverse problem mo as the physical instantiation of the input that you want, right? And that's what we will look at in module number 3. We'll give a specific type of inverse problem at ipapakita natin na nagiging meaningless yung modeling process pag naive reconstruction lang yung ginawa natin. Meaning the effects of the perturbation to the solution is very huge na dapat sinasama siya sa pagbe-build up ng solution. So basically, ito yung siguro unang technical discussion ng inverse problem na makikita natin kasi medyo philosophical lang yung tinitingnan natin na last time nag-describe tayo ng properties pero wala pa masyadong math na involved. All right. So ngayon titingnan natin via a specific example. So I think I have introduced module number 3 and we went through the module objectives. So these are the things that you will need to check. I don't think we can have homework number 3 or a technical homework this week. Pero siguro I'll upload homework number 3 later this afternoon. Pero ano lang siya, reflective post. Ano? So parang ano lang siya. You'll write a one paragraph essay or 3 to 5 sentences about your Math 191 experience so far, right? Kasi gusto ko rin makuha yung feedback kasi napakalaki nung napaka-diverse ng backgrounds nyo, no? So may mga seniors, may mga juniors. I want to see how you are doing in the course para ma-adjust ko yung mga susunod na modules, okay? Yeah. So the type of this week we will be considering a specific inverse problem, or in this module a specific inverse problem, which is called the deconvolution. Convolutions and the associated inverse problem, yung deconvolution, these are very useful inverse problems, especially in signal processing. So doon lagi ginagamit yung convolution. Pero ngayon titingnan muna natin siya in a more specific way. Huwag muna nating ilagay yung applied side nito. Tingnan muna natin yung mathematical side. So i-build up natin yung theoretical problem, but I want you to know that pwede itong tingnan, yung convolution saka deconvolution, siya yung inverse problem na involved kapag halimbawa, meron kang audio recording. And your audio recording has some noise to it. Nag-record ka, tapos may mga dumaraan na sasakyan dun sa background, so nare-record yung sound ng mga sasakyan or may tumatahol na aso or tumitilaok na manok. So you can consider them as noise and they are incorporated in your recorded audio. So pwede mo siyang tingnan as a convolution of two signals. The convolution of your actual voice or your actual or the sound that you're actually recording convolved with, say, the barking of dogs outside, right? And the output nung dalawang signals na yon, yung convolution ng dalawang signal yun na yon, ay isang noisy recording. I mean, recording with the presence of background noise. So the forward problem is we look at how we predict ano yung nagiging epekto nung pagkakaroon ng tumatahol na aso sa labas at saka ikaw na nagre-record, ano yung output na recording. So yun yung forward problem. The inverse problem is I have the noisy recording. So I have the recording with your voice and all the noise that came from the background. Ang gusto kong magawa ay ma-deconvolve silang dalawa to separate the noise from the actual recording. Right? So ang input mo sa inverse problem, yung noisy recording, tapos ang output mo, yung original na intended audio to be recorded. Can also be looked at the blurring or sharpening a blurred photo na ang iyong input ay isang nice scenery, tapos ang process mo ay taking of pictures. Kaya lang medyo magalaw yung kamay mo when you took the photo. So pwede mong tingnan to as the convolution of the action nung kamay mo and the actual photo being the actual scene being photographed. So sa inverse problem, meron kang blurred photo. Ang gusto mong reconstruct ay yung sharpened photo. Alright? So para siyang convolution. Pero yung modeling nila medyo komplikado. So tingnan muna natin siya from a purely mathematical perspective. So here, eto na, yung mga binago ko dun sa paragraph na to. So medyo significant sila. So in the convolution process, we will consider two continuous functions, a function f and a function psi. Okay. In general, they could be piecewise continuous functions. But for simplicity, para hindi masyadong generic yung titingnan natin, sinabi ko na lang sila ay continuous over the set of real numbers. Now, the convolution operator with respect to the function psi is the operator that will transform a continuous function na input into another continuous function, such that f, the input, is mapped to the convolution of the fixed function psi. So naka-fix si psi, given yan sa problem, convoluted by f. In general, pwedeng hindi fixed si psi. So pwede mong tingnan si operator A as a bivariate operator na dalawa yung inputs niya, psi and f. Pero sa atin, para maging mas simple na lang, if i-fix na lang natin si psi, siya yung parang pinangko-convolve natin, siya yung parang background noise doon sa ating recording example, ano? Or this is a fixed phenomenon, tapos mag-i-input ka lamang ng another function, right? So if you have an input function f that is continuous on the set of all real numbers, you have a fixed psi, then ang convolution operator will work this way. So ang image ni f ang image ni f under the convolution operator is simply the integral ni psi of y times f of x minus y all over the set of real numbers. So remember, si AF ay isang function. Alright? So ang ibig sabihin ng notation na to ay kukunin ko muna yung convolution ni f, makakuha ko ng isang function. So this guy is another function, tapos magpa-plug in ako sa kanya ng x. So si AF ay actually isang function ni x. But how do you compute the image of x under the image of f under the convolution operator? It is simply this guy. Kukunin mo yung convolution ni psi together with f by integrating the product of psi and f, pero yung pangalawang signal, yung input mo ay translated by some value. So you will integrate the product of psi of y, pero si f nag-translate ka by y units. So yung second factor mo ay x minus y. But in this integral, we will be in this expression, we are integrating with respect to the variable y. So si x ay treated to be a constant. Okay, so maybe we can pause here and look at specific examples. Okay, hold on guys, excuse me. So from time to time, I need to mute myself kasi umatake na naman yung runny nose ko. Kahapon pa tong 151, so pasensya na. Pero yeah. So hindi ako madadrop, mag-mute lang ako from time to time, alright? So let's see a specific example. Say an easy one first. Say, anong epekto kapag say constant function si psi? Alright? So ano yung nangyayari dun sa signal na makikita natin, right? So halimbawa, si psi I defined psi of x, for instance, so example number 1 is the constant function 1. Gawin na lang natin siyang conditional function, piecewise continuous function, para hindi tayo mag-i-improper integral because here, the integration should be performed all throughout the set of real numbers. So yung integral from negative infinity to positive infinity, mag-ano pa ako ron, mag-i-improper integral pa ako, hatiin ko siya sa dalawa. So to make it simpler, to make the example simpler, let's consider psi, the fixed function, to be, say, equal to 1 over the interval 0, 1 and 0 elsewhere. Okay. Usually, ganito naman yung itsura nung pinangko-convolve natin because if you have a finite signal, so nagta-turn on and off lang yung signal psi, alright? So ibig sabihin, naka-active lang siya for a finite amount of time, tapos tina-turn off na siya outside of that finite interval, right? So ang tawag natin sa set kung saan ang isang function ay non-zero ay yung support niya. So we can say that psi is supported on the closed interval 0, 1. Okay, so ang support ni support ni psi ay equal kay 0, 1. Kasi outside of 0, 1, siya ay 0 na. Okay? So yung support ng isang function ay yung set kung saan siya non-zero. Alright? And this will make our integration much easier now. Kasi instead na mag-integrate from negative infinity to infinity, mag-integrate na lang ako dun sa support ni psi. Kasi, tingnan nyo to. Si psi ay multiplier. So pag nag-zero si psi, 0 na yung buong integral no matter how f looks like. Right? So ibig sabihin, instead of negative infinity to infinity, if this is our psi, I can just integrate from 0 to 1. Pinadali ko lang. Pero sa totoong buhay, in general, negative infinity to positive infinity yan. Pero since psi and f represent signal in the real world, sila yung usually pinagko-convolve natin, so finite lamang usually yung support ng dalawang sets na yan or dalawang functions na yan. Okay? Now, sige, pili kayo ng function f. Yung madali lang na-integrate. So, titingnan natin yung convolution operator with respect to this function psi. Alright? So, ano kaya pwede natin tingnan? Sige, madali lang. Identity function, f of x equals x. Then, let's compute the convolution of psi and f. So, the convolution of f and psi, all right? So si psi kasi finifix natin for an operator a ay yung function of x, right? So computing ko muna ito, tapos magpa-plug in ako ng x. So ito ay isang function of x, and this is defined to be the convolution psi star f of x. And again, this is supposed to be negative infinity to infinity ng psi of y, okay? The fixed function times a translation of the given input, dy. Kasi may time delay na tinatawag. So kaya may minus y dyan. Kasi titingnan mo yan na hindi sabay na nag-occur yung dalawang signal. May konting delay dun sa signal f. Alright? And let's see what happens, right? Now, psi is supported only on the interval 0 to 1. So 0 si psi sa labas ng interval 0, 1. So ibig sabihin, from negative infinity to 0 and 1 to positive infinity, 0 yung value ng integral. So we can just integrate from 0 to 1. Masaya tayo kasi wala nang improper integrals na involved dyan. And then this will just be 1. Okay? 1 lang yung value niya over the interval 0, 1 times the function f but evaluated at x minus y. So our function f is the identity function x. Magpa-plug in tayo dito ng x minus y. So we'll have an x minus y over here. And just remember, we are integrating with respect to the variable y. Okay? So and then we can do the integral now. This will just be the integral from 0 to 1 ng x minus y dy. And again, remember, we are integrating only with respect to the variable y. So lahat ng x's na nakikita natin will be treated as a constant. Okay? So integral ng x with respect to y ay magiging ano lamang? Xy minus integral ng y with respect to y. That's going to be y squared over 2. And then all of this evaluated from y equals 0 to y equals 1. Okay, is that clear? Ito lang yung nakakalito sa convolution kasi dalawa yung variables na involved. Alright? Pero dun sa integration, si y lamang yung treated as a variable. Si x ay treated as a constant because again, sa y tayo nag-integrate. Dun sa pinang-time delay natin yung integration. Okay? So here I plug in y equals 0 and y equals 1, then take the difference. So understandably, may matitirang x's doon sa final answer, and that's acceptable because remember, the convolution is a function of x, right? So si a of f ay function ni x. So okay lang na may makita tayong x dito sa final answer. So that means here, what do we get? So we get x minus 1/2. Tama ba? Tapos minus 0. So this would be x minus 1/2. Tama ba integration ko? 1, 0, minus 1/2. I think so. All right. Kinakabahan ako sa integration kasi maaga pa. So yan. So x minus 1/2. So that is the convolution of this piecewise function. Ano kaya ang pwede natin ditong itawag? Ang graph kasi nito ay 0 siya, tapos sa interval 0, 1 siya ay 1. So ganito yung itsura niya. So para siyang box or hat function. Tawagin natin itong hat function, the unit hat function. Ano? Kasi mukhang top hat yung kanyang graph with the identity function. All right? So that's how the convolution operator is performed. And actually here we solve a forward problem. So we know the process. The process is a convolution operator with respect to the hat function psi, the unit hat function psi, and our input is the identity function x. Sinolve natin yung forward problem of looking at what's the effect of the convolution process doon sa identity function. What we get back is not the identity function anymore, but the translation of the identity function. So medyo nagkaroon na ng time delay dun sa identity function, naging x minus 1/2 na siya. Okay? Any questions with that example? Clear pa? Okay, hopefully it is. Just let me know if there are some questions. Now, kapag ka ang support ni psi and or ni f, or in general, pag parehas na sila, sige. Kapag ka ang support ni psi at saka ni f ay yung set of all positive, may typo pa rin. Set of all positive real numbers. Actually, sama na natin si 0. So non-negative. If psi and f are non-zero on the set of non-negative real numbers, then the integration interval can be further toned down to this integral. To this interval. Mag-integrate na lang tayo from 0 to x. This can be proven, pero more of sa integration theory yung proof. But believe me for now that kapag ka ang support ni psi at saka ni f ay set of all positive real numbers, then the integration from negative infinity to infinity can be reduced to integration from 0 to x. Okay? So nagkaroon ka ngayon ng isa pang variable dun sa upper bound. Yun ay kapag meron ka pa kasi magkakaroon ka ng improper integral Improper integral ka dun sa upper bound. So if you do the math carefully, you can show that instead of integrating to positive infinity, you can just integrate until x. But this x is the variable here in the right-hand side. Okay? So ito yung mga nagiging, pero hindi realistic na signal to kasi kapag ka nagbo-broadcast ka naman ng signal, hindi siya ongoing forever. Alright? Laging finite time steps lang naka-turn on yung iyong signal. But anyway, this is for a more generic theorem. Now, let's take a look at an example of this. Para makita natin paano sinusolve yung forward problem. And this forward problem actually is well posed kasi kapag pag naka-fix si psi, meron kang given input f, lagi tayong may mahanap na unique solution doon sa convolution. And it can be shown that a small perturbation of the input will yield correspondingly small change in the output. You can do the math, pero that should be straightforward. Mag-i-integrate ka lang dito ng plus yung noise function psi evaluated at x minus y. And if this function is small, yung integral niya over, say, the support should also be small. Kaya well-posed itong convolution. Pero makikita natin mamaya yung inverse problem na the convolution ay hindi siya well-posed. So nagiging ill-posed yung inverse problem. But anyway, before going there, let's consider one example of a signal that is supported on the half plane 0 to positive infinity. So let's consider this as our second example. Halimbawa si psi ay e to the negative x when x is in 0 to positive infinity and it is 0 elsewhere. Oh, maybe siguro mamaya maybe siguro, super redundant. Mamaya siguro ay i-upload ko, i-update ko uli yung module para i-include yung definition ng support. Alright? Para para hindi kayo mahirapan na nagte-take note pa masyado ano. So, medyo minsan meron mga topics na ayoko na sanang banggitin. So, wala siya dun sa original module. Pero I can't help myself when delivering the lecture live na nababanggit ko rin siya. So, sige, idadagdag ko siya sa module. Ano yung ibig sabihin ng support? Pero anyway, ang support lang naman ay kailan or saang set non-zero yung ating given function. Alright? So, for instance, in this case, the support of psi is the half plane or the half real line 0 to positive infinity. Kasi nag-zero na siya elsewhere. And say our function f of x is say, sige, periodic signal na rin. Sine x when you are in 0 to positive infinity and 0 if you are elsewhere. So pwede mo itong tingnan na sa signal na nagsisend ng sine wave kapag ka naka-zero ka na to positive infinity, tapos naka-turn off siya kapag ka negative pa yung value ni x. Alright? And then let's compute the convolution of f. So again, we are working with, we are solving the forward problem. What is the convolution of f with respect to psi? Or what will happen if we convolve f with the fixed function psi? All right, so this will be a of f of the variable x, and this is psi star f times x, and this would be the integral supposedly from negative infinity to infinity of psi of y, f of x minus y, dy, all right? But since by the remark in the module that if the functions are supported on 0 to positive infinity, you can get rid of the improper integrals and instead you integrate just on 0 to x. Tapos ano si psi of y? Si psi of y ay e to the negative x, e to the negative y. Kasi psi of y siya. So, e to the negative y times sine ng x minus y dy. All right? I hope the setup makes sense. Okay? And okay, so tingnan natin kung nagme-make sense yung setup para hindi tayo para ma-correct na natin kung may mistake at this particular point. So this is we integrate this with respect to y, so lahat ng y's mawawala, so that's fine. Matitira yung mga x's kasi yung mga y's papalitan lamang natin ng 0 to x. So this is good. All that will remain after we perform the definite integral would be the variable x. Wala na yung mga y. And that should be the case because our convolution is just a function of the variable x. Okay? Ngayon ang problema, paano natin to evaluate? Can anyone remember how do we evaluate this integral? Ano yung technique na gagamitin ko para ma-integrate to? Tandaan niyo pa ba? Or kinalimutan niyo na to? Nakapag 37 na naman kayo, di ba? Tama ba? Nasa 37 nga ba to? Techniques of integration nasa 37, no? Or masyado pang maaga para mag-integrate tayo. So here I'll use, hindi nyo tanda or ayaw nyo lang mag-recite?
Algebraic po ba, sir?
Nope. Try again. Yun yung problema
Or...
sa techniques of integration. Ang daming options, ano? Sige. Sirit na? So meron kang product ng dalawa. Tapos yung... Yeah, madudulas na ako. Pero... yes. Thank you, Denmark. Integration by parts. Trisha, you also said integration by parts. Yes. We need to integrate by parts here. Actually, hindi lang once. Kailangan ko mag-IBP twice. So, siguro here, I can let u, sa unang IBP, ang u natin ay e to the negative y. Tapos, ang dv natin ay sine of x minus y. Okay? So, ibig sabihin, ang du ay negative e to the negative y. Tapos ang v ay cosine ng x minus y. Dito nakasama yung dy. Tama ba? Ang derivative nito ay, or may negative sign. Hindi, tama. Ang derivative nito ay negative sine ng x minus y, tas chain rule will kick in. Remember, we're differentiating with respect to y. So derivative ng x minus y with respect to y ay -1. So ang derivative nito ay sine of x minus y with respect to y. Right? So integration by parts tells us that this will be equal to uv. So that's e to the negative y times v, which is cosine of x minus y, evaluated from 0 to x, minus the integral from 0 to x ng v du, uv minus v du. So it's going to be cosine ng x minus y v du times negative e to the negative y dy. All right? So yeah, I can write it as, yung negative sign dito, pwede ko na siyang ilabas to make it a plus. Right? Kaya lang, eto, problema natin tong integral na to, so mag-IVP pa ako ng isa pang round. So now I will, in this round of IVP, I will use u to be equal to e to the negative y. Tapos sana mag-repeat na siya. Tapos, ang gagamitin kong dv ay cosine ng x minus y dy. So that means du would be negative e to the negative y dy. Kulang ako ng dy kanina rito. Tapos ang v natin ay try natin ang sine x minus y. So pag anong derivative ng sine x minus y, that's going to be cosine ng x minus y times -1 kasi nag-differentiate tayo with respect to y. Kaya lang cosine lamang yung meron ako, so this should have a negative sign in front of it. Okay? All right, so that would be our substitute for this integral over here. So let me just copy the first term here. Duplicate ko lang yan. Tapos plus, okay, uv. Ano ang ating u? Ang u natin ay e to the negative y. Ba't ko nilagyan ng parentheses? E to the negative y times v, which is negative sine of x minus y, evaluated from 0 to x minus the integral from 0 to x nung matitira, v du. So it's going to be negative sine ng x minus y. Ang du ay negative e to the negative y dy. Okay? So essentially, this is e to the negative y cosine ng x minus y from 0 to x plus e to the negative y, negative sign on that. Ipat ko na yung negative dito, minus sine ng x minus y evaluated from 0 to x, and then ito ay minus 0 to x ng e to the negative y sine of x minus y dy. Tama ba? Hopefully tama yung integration ko. Ang sarap ang pagising ng integration by parts, ano? At hindi lang isa, pero dalawa. I'm quite happy right now kasi ito ay kamukhang-kamukha ng definition ng convolution, which is basically our right-hand side over here. So this will imply na yung twice ng convolution ng AF of x. Alright? Again, why? Because here, yung AF of x ay equal dito. Okay. So, kaya lang, so this guy ay equal dito. Ito ay transpose ko dun sa kabilang side ng equation. So, I will have twice of this dun sa left-hand side. Tama ba? Tingnan nyo to, compare natin. Ito yung unang-unang right-hand side natin. Equal daw siya dito. But this guy is the same as this guy. I hope this rings the IBP bells na natutunan nyo sa 37. Pag may cyclic pattern, yung ini-integration by parts, gusto nyong ma-recover kung ano yung ini-integrate nyo by parts originally para ma-transfer siya doon sa kabilang side ng equation. So this guy plus this guy is twice that integral. Pero ano nga ba tong integral nito? Ito yung convolution ni psi at saka ni f. So I can just write it as AFX. Okay? And what we're left with would be ito na, yung right-hand side na. Okay. Then Kailangan natin gawin ngayon, plug in. So remember, we will be replacing all y's by 0 and x and then subtracting them from each other. So we'll have what? E to the negative x cosine ng x minus x 0 minus e to the 0 cosine ng x. So ito yung substitution nito. Plug in x, then kunin yung i-plug in si 0, tapos i-subtract yung results. Tapos we'll have minus this quantity. Ito naman. Ito yung i-evaluate natin. So this would be e to the negative x sine of 0 kasi magiging x minus x minus e to the 0 sine ng x. Tama? So this guy would be cosine ng 0 ay 1. So e to the minus x, then minus cosine x. Sine of 0 is 0, so this guy vanishes. So magkakaroon tayo ng plus sine x. All right? But this is twice the convolution. So therefore, we can say that the convolution of sine f, or the answer to our forward problem, is 1/2 e to the minus x minus cosine x plus sine x. Ang hirap is ang haba ng solution ng forward problem, no? So imagine how convoluted it is, pun intended, na hanapin or isolve yung inverse problem. Okay? So now does the convolution operator makes more sense? At least computationally. I hope it does. Ano? So practice lamang ng integration. So yung application siguro pag-usapan natin, if you want to work on signal processing as your SP, I probably can help you, pero it's a lot of convolutions. Ano? Yung mga naghahanap ng topic dyan. So pwede natin gawin yung signal processing na puro convolution yung gagawin. Okay, so some properties of the convolution. So a convolution is an operator from an infinite dimensional space, kasi nga space of all continuous functions, onto the set of all continuous functions. So pag meron tayong continuous function, ang output ay isa pang continuous function. Now, there are some properties to the convolution. Actually, dalawa lang yung sinulat ko originally. Yung convolution operator natin ay linear. Because it satisfies two properties, L1 and L2. We say an operator is linear if it is additive. Kapag ang image ng sum ay equal sa sum ng images, then we say that operator is additive. And then if it preserves scalar multiplication, if the image under an operator of a scalar multiple of f ay equal lamang sa scalar multiple nung image ni f under the operator, then it preserves scalar multiplication, right? So ang image ng scalar multiple ay scalar multiple ng image. If these two properties are satisfied, then we say that we have a linear operator. So si D ay linear operator. So we already know some examples of linear operators. Number one, derivative operator. Kasi kapag nagdi-differentiate tayo ng sum, kung si D ay differentiation, remember, ang derivative ng sum ay sum ng derivatives. So additive ang derivative operator. Napreserve ba niya yung scalar multiplication? Yes, kasi ang derivative ng constant times a function ay constant times the derivative of the given function. So indeed, differentiation is a linear operator. Another example is the integral operator. Ang integral ng sum ay sum ng integrals. Ang integral ng isang scalar multiple ay scalar multiple ng integral. So those are two examples of linear operators. And then you can add to your list the convolution operator. Maybe you can think of how to prove that the convolution operator defined in equation 3.2 ay linear. Siguro ilalagay ko yun sa problem set. Prove that the convolution operator defined in equation 3.2 is a linear operator. So all you need to do is to check pag meron akong arbitrary functions f and g, ang convolution ba ni f plus G ay equal sa convolution ni F plus convolution ni G. And thus, the convolution preserves scalar multiplication. I think that is easy because napreserve ng integral, ng simple integral yung scalar multiplication. Ang convolution is nothing more but an integration of a product of two functions. So I guess this is more straightforward. Actually, I guess this is also straightforward. So you can try practicing writing a proof that the convolution operator is linear because I'll put it in the problem set. Tapos you can consult with me before the problem set kung gusto nyo ipa-check yung solution nyo doon sa question na yun. Alright? So, yeah. Ano yung implication ng pagiging linear ng convolution operator or in any operator in general? We're interested in them, in linear operators, kasi kapag ka linear operator ka, pwede nating isulat or pwede nating i-approximate yung action ng operator as a linear system. Alright? So this might be continuous models. Ibig sabihin, nag-work siya sa mga functions which is a continuous data. Ibig sabihin kasi function siya na ang domain niya ay lahat ng real numbers. So walang gap. Alright? Hindi siya discrete, I mean. Pag sinabi kong continuous, hindi discrete. So ibig sabihin, tuloy-tuloy yung set of data na nakukuha natin sa operators na to. So kapag meron kang gantong symbolic o meron kang continuous model, hindi natin siya pwedeng i-feed sa computers right away. Kasi hindi design yung computers mag-isip in terms of continuous functions, in terms of continuous data, and so on. Kailangan discrete and finite yung input para sa mga computers. Ang kagandahan kapag meron tayong linear operator, kaya natin siyang isulat or i-approximate by a system of linear equations. That's why from now on, we will limit our inverse problems to the linear ones, para lagi natin pwede itong ipa-compute sa ating mga computers. Alright? But keep that in mind that the convolution operator is linear. That will come into play when we discretize the continuous model. Right? So medyo komplikado yung pagko-convolution, especially if you're doing it by hand. So siguro next week, I'll show you a way on how to do it on a computer para hindi tayo lagi nagko-compute ng convolution paulit-ulit. Pero isa sa makikita nating effects ng convolution ay ginagawa niyang mas smooth yung isang signal. Kaya laging kino-consider to sa signal processing kahit yung convolution, because you can design or you can design yung fixed function psi para makakuha ng isang napaka-smooth na signal. Kasi in general, convolutions are smoother than the input functions. Okay? Pero to make our discussion simpler, dun sa susunod na example, mag-consider lang tayo ng periodic functions. Makikita nyo mamaya kung bakit mas simple yung ating example kasi one periodic yung pinili natin. We say a function is one periodic if the function value at x is equal to f of x plus 1. Ibig sabihin, paulit-ulit lamang yung itsura ng function over intervals of length 1. So, in effect, kapag meron kang function na one periodic, hindi mo kailangan tingnan yung behavior ng function doon sa buong domain. For instance, if it is defined on the set of real numbers, you don't need to sketch the graph of f over the entire real number because it is one periodic. So, ibig sabihin, kumuha ka lang ng isang slice o isang parte nung graph over an interval of length 1. Tapos yun lang, paulit-ulit lang siya, pinagdidikit-dikit mo lamang siya. Kasi nga, nauulit lamang yung function value. So, pwede mo tingnan to as a cyclic function. So, meron siyang cycle. Cyclic yung function kasi paulit-ulit lang siya habang nag-add ka ng 1. And this is similar to your sine and cosine functions na hindi nga lang 1 yung period. Ano nga ang period ng sine and cosine? 2pi, ano? Kasi kapag meron kang sine ng x, equal lagi yan sa sine ng x plus 2pi for all x from 0 to 2pi. Alright? So yung sine function, yung cosine function, sila ay 2pi periodic. Yung tangent function, cotangent functions, sila ay pi periodic. Pero ngayon, ang titingnan natin, ang consider lang natin yung mga 1 periodic functions. Alright? So, dahil 1 periodic yan, pwede nating ibaba lahat ng computations to an interval of length 1. Kasi kung ano nangyayari kay x, yun din yung mangyayari kay x plus 1. Paulit-ulit lang yan in a cycle. So nakita nyo kung paano ko pinapalit yung problem para yung computations maging mas madali. So halimbawa, kanina, dun sa integration from negative infinity to infinity, dun sa convolution, okay, kung si f ay 1 periodic, ibig sabihin kailangan ko na lamang i-integrate ito over an interval of length 1. Kasi paulit-ulit lang naman yung magiging itsura niya outside of that interval. Okay? So pwede ko na lang i-consider yung isang slice niya from 0 to 1, and whatever the behavior on that interval 0 to 1 will carry on for all other intervals of length 1. Right? So restrict natin yung so ibig sabihin sa convolution operator natin, ang domain na natin ay set of all continuous one periodic functions. Right? Now, we'll now give an interpretation to the fixed function psi na ginamit natin doon sa convolution operator. The fixed function psi is called the point spread function of the convolution. All right. Siguro later, when you go to some more practical applications, saka ko na lang ikwento kung bakit siya point spread function yung tawag. Other texts calls it the device function, the impulse response, the blurring kernel. Tinatawag siyang blurring kernel kapag pinang-model natin yung convolution for image processing. Kasi parang siya yung nagko-cause ng pag-blur ng image. Obviously, it can also be called the convolution kernel or the transfer function. Depende kung anong application area yung ginagamitan mo ng convolution. Pero for us, gamitin natin yung general term na point spread function or the PSF. Okay? Tapos, di ba dun sa convolution operator natin, dapat fix yung una. Though in general, hindi kailangan. Pero sa ating definition, naka-fix dapat yung isang, naka-fix dapat si psi para isa lang yung input doon sa ating convolution. Alright? Si f lang yung input sa convolution. So in the example that will follow, I will use this to be the building block for psi. Hopefully, online pa ako kasi nag-flicker yung ilaw ko rito. So, hindi ko alam kung nagba-brown out ng mabilis. But, can I get a thumbs up kung nandito pa ako? Okay, thank you, Prince, Neo, Trisha, Victor, and so on. Yeah, thank you, everybody. So ngayon, bubuin ko yung specific psi para dun sa i-consider natin na convolution process. Now, gagamitin ko siya, ang gagamitin ko para mabuo si psi ay itong function na to. Si psi sub 0. Si psi sub 0 ay yung function na x plus a squared times x minus a squared times a constant that depend on a. Si a, pwede natin siyang piliin to be any number from 0 to 1/2. Okay? So, define natin yung convolution, yung fixed function psi using this function which is defined from negative a to a. So, mula sa, mag-fix ka muna ng a from 0 to 1/2, alright? 0 and 1/2 not included, pili ka ng a, tapos i-define mo itong function na psi sub 0 over the interval negative a to a. Now, okay, these are self-explanatory, quadratic functions lamang. So mga binomials lang yan, tapos dadagdagan natin siya ng, square ng binomials, tapos ipa-plug in ko si a. Meron ka ditong scaling constant, c sub a. Ano yung scaling constant? Siya lamang yung 1 over the integral ng x plus a squared times x minus a squared from negative a to a. Now, inintroduce ko lang tong normalization constant na to para yung integral ni psi ay maging equal kay 1. Para hindi masyadong malaki yung value ni psi sub 0. Okay? I want to keep its integral to be equal to 1. So essentially, pag in-integrate ko ngayon si psi sub 0, the integral ni psi sub 0 of x dx from negative a to a, kasi dun lang siya defined, alright, from negative a to a. Ito ay maging equal sa integral from negative a to a ni c sub a times x minus a squared, x plus a squared, dx. Pero si CA ay constant, so lalabas siya. So magiging integral lang ng negative a to a, x minus a squared, x plus a squared dx. Pero si CA ay 1 over the same guy. So that means, that means this integral is just equal to 1. So kailangan ko yung scaling constant para lang hindi masyadong malaki yung value ng integral ni psi sub 0 para hindi mag-blow up yung itsura ng graph na convolution natin mamaya. Alright? You could have gone away with the scaling constant pero masyadong ma-scale. Either ma-shrink o ma-expand yung function f natin. But we don't want to do that in convolution, so usually unit dapat yung pang-convol. Right? Tapos, yun yung property ng building block ng ating convolution. Now, I will define the fixed function psi now to be copies ng psi sub 0. Okay, so mangyayari, tingnan natin to. So, kapag ka si A ay 0.04, is that correct? Yeah. Kung si A ay 0.04, ito yung graph nung psi sub 0. So, ito yung y equals psi sub 0 of x. Okay? Tapos, ang gagawin ko, yes, Denmark.
Sorry po, sa napindot lang po.
Okay, sorry. Akala ko may tanong ka. Alright, that's fine. Okay, so yan si psi sub 0. Tapos, para makuha si psi, yung pang-convolution natin, kukopyahin ko lang to all throughout the real number line. So you see, its length is a. Its length is 2a. So 0.08 lang yan. So kukopyahin ko lang to sa mga intervals ng itsura ay n minus a at saka n plus a. Tapos magzi-zero na siya everywhere. Right? Where n is an integer. So for instance, si a ay 0.04, tapos halimbawa si n ay 0. Pagka si n ay 0, nasa interval negative a to a tayo, yun lang yung original graph. So from negative 0.4 to 0.4, eto siya. Ito yung portion ng convolution na yun. Tapos, kailan uli siya magiging non-zero? Kailan uli magiging psi sub 0 yung value ni psi? Kapag ka ang n ay equal kay 1, ibig sabihin, kokopyahin ko si psi sub 0 sa interval ng itsura ay 1 minus 0.04 hanggang 1 plus 0.04. So that would be from 0.96 to 1.04, 0.96 to 1.04. Ito yung second copy ni psi sub 0. So ito si psi sub 0, ito si psi sub 0. Alright? Tapos kapag ka si n ay ginawa yung negative 1, so ibig sabihin, kokopyahin ko na naman si psi sub 0, pero ngayon sa interval na negative 1 minus 0.04, comma, negative 1 plus 0.04. So that's going to be what? Negative 1.04 hanggang negative 0.96. That's that interval. So ito yung third copy is psi sub 0. Oops. Then I'll just do this forever. All right? Infinitely many copies ng psi sub 0 doon sa buong real number line. Yung kabuuan na yon ng lahat ng kopya ni psi sub 0, yun yung ating PSF na psi. Alright? So okay lang kung kailangang i-digest later ko yung function na psi, pero kopya lamang siya ng psi sub 0. Alright? Ang hirap naman ito kasi yung fixed function pa lang, ang hirap niya nang i-describe, ano. Pero at least graphically, I hope it makes sense, ano. Kahit yung math later na lang. So tingnan natin tingnan niyo muna yung visual representation niya. Because remember, gagamitin ko to pang convolution. So napaka-convoluted talaga ng process. All right? Now, so yan yung function f. So tingnan natin, paano nag-a-act si psi under the convolution process. Okay? Well, the forward problem is we now know the fixed function psi, right? And if you will be given a function f, ang forward problem ay hanapin natin yung continuous function g such that G is equal to the image of F under the convolution operator. Alright? I guess madali siyang gawin kasi kailangan lang nating i-perform yung integral, right? The integral from negative infinity to infinity ng psi of y times f of x minus y dy. Pag na-compute nyo yung integral na yon, you have solved this forward problem. Okay? Now, if you'll do that, actually ginawa ko siya numerically with one example. Halimbawa, yung function ko ay itong one periodic function na ito. Right? It's a conditional function. So from 0.1 to 0.15 equals siya kay 1.5. From 0.2 to 0.3 siya equal kay 1.3. From 0.4 to 0.6 siya equal kay 5x minus 2. From 0.7 to 0.9 equals siya kay 1. Tapos elsewhere, sa interval 0 to 1, ang value niya na ay 0. Okay? So ito si function f of 0. And then the input function f is basically copies of this function. Remember, restrict natin yung kinoconsider natin sa mga one periodic function. So ibig sabihin, kailangan ko lang makita paano nagbe-behave si f sa isang interval na ang length ay 1. So ang ginawa ko sa example na to, i-illustrate ko anong itsura ni f dun sa interval 0 to 1. That happens to be the function f sub 0. And since I know what the behavior of f on the unit interval 0 to 1, I can just make copies of it para makuha yung itsura niya all throughout the real number line. So if you will plot this function, ito yung makukuha natin. Ito yung graph ng function f. And you see this function is continuous, but this is not differentiable on the entire interval. Kasi meron kang mga sharp turn, right? Halimbawa, ito sharp turn. Tapos dito actually, meron kang impulse na ganito. So, hold on. Yeah. Hindi siya continuous. Sorry, kailangan ko palang Yeah, kailangan ko i-edit yung definition ko ng convolution. Dapat siya ay piecewise continuous talaga. Kasi yung example ko pala dito ay piecewise continuous. Though mag-work pa rin yung definition, tama pa rin siya kasi yung convolution defines siya sa continuous functions. Pero hindi lang continuous functions yung pwedeng maging input niya. Pwede ring piecewise continuous. I thought pwede ko siyang ibaba sa continuous, kaya lang yung example ko pala ay piecewise continuous. Hindi siya continuous kasi sa 0.1 ang value niya ay 1.5. Pero from 0, right before you arrive at 0.1, ang value niya ay 0. So discontinuous siya sa 0.1. Alright? Pero it's piecewise continuous kasi yung mga pieces dito sa continuous function na to ay continuous. So yun yung ibig sabihin ng piecewise continuous. Piecewise continuous siya kasi continuous yung mga function dun sa conditions. Each of the pieces is continuous. Pero as a buong function, hindi siya continuous. Right? So if this is our input to the convolution operator, kaya nating isolve yung forward problem by just evaluating AF, right? And in that case, ito yung makukuha natin na convolution, right? So again, this is obtained by computing AF of x to be the integral from just the interval 0 to 1, kasi nga one periodic naman yung function. I don't care what happens outside of this interval kasi paulit-ulit lang naman yung magiging value nung convolution on an interval of unit 1. Tapos this would be psi of y, f of x minus y dy. Right? Though mahirap siyang gawin by hand, so I used a software para ginamit ko si MATLAB para compute and symbolically itong integral to. I'll show you the MATLAB code to you next meeting, But after performing this, I got the image under the convolution operator. And what you can notice here, anong ginawa nung convolution operator? Any observation? Ano yung nangyari after the convolution? At least visually. What can you say about the convolution? Ano yung striking effect ng convolution from dun sa function f? Anyone? Kailangan ko magtanong para makapagsip ako ng coffee. All right. Yes, Neo, that's right. Lumambot, sir, yung lines. Yes, because here you have sudden turns, right? So tapos dito medyo curvy na yung mga yung turns. Ano, hindi na siya yung sudden turn. Put more slopes on the discontinuous areas. Yes, you can treat it that way, Victor. Ginawang pong smooth yung curves. Yes, as I mentioned, isa sa ginagawa ng convolution operator ay ginagawa niyang mas smooth yung yung original function. So from a very sharp turn here, makikita nyo dito medyo lumambot na siya. And I guess there's a little bit of a translation. Okay, nagkaroon ng konting delay. Kasi rito sa 0.7 nagkaroon ka ng turn. Pero dito yung turn nangyari na right before 0.7. And that's understandable kasi translated, di ba, si f. Dun sa integral, meron kang x minus y. So basically yan, isa yung effect ng convolution. Ginagawa niyang mas smooth or mas differentiable yung function. So and then now, we just don't have a piecewise continuous function, but now the convolution is continuous. Kasi wala na dito yung hindi na katulad kanina na meron kang point of discontinuity. Naging smooth na siya, and along smoothness kasama yung pagiging continuous. And this is the solution to the forward problem. Ito yung sa forward problem. Kinuha ko yung convolution, tinumpute ko lang siya, tapos yung forward problem. Okay? The more interesting problem is to solve the deconvolution process. I mean, we want to solve the inverse problem. What if, you can think of it as, say, pwede mo itong tingnan, halimbawa, graph ng isang recording. Ito yung gusto mong i-record. Pero dahil may background noise, ito yung nakuha mong output. Alright? So ang gusto nating tingnan, what was the original recording without the influence of the function psi na pinang-convolve natin. So meaning your data will be this guy, and what we want to get is a reconstruction of the input function. That's the deconvolution process. That's the inverse problem. More formally, that means we want to find the function f such that for a given g, we know that g is equal to the convolution of f, or the image of f under the convolution operator with respect to psi. Right? Now, paano natin yun isosolve? Madali ba siyang isolve? Actually, hindi. Kasi ang mangyayari sa atin noon ay ganito. Ito yung equation. Di ba, for ang inverse problem, find f such that ang a of f ay equal kay g. For g is a given function. So si g ay given. Siya yung data. Right? Pag in-expand natin yung itsura ng convolution operator, ito siya. Integral from negative a to a of psi of y f of x minus y dy. Alright? Equal kay g of x. Hold on. Mali pala yung sinabi ko kanina, no? Sabi ko ay integral from 0 to 1. Dapat siya ay integral na lang from a to... Integral siya dapat from negative a to a. Bakit siya integral from negative a to a? Magsisimula ka talaga sa integral from 0 to 1. Pero dahil si psi ay 0 siya, aside from intervals of n minus a to n plus a, alright? Remember, ang gagamitin kong n ay 0 kasi nasa 0, 1 tayo. Doon sa mga specific intervals of the form n minus a to n plus a, magma-matter lang doon sa convolution kasi andito lang tayo. So, gagamitin lang natin ay yung from a to a. Kasi andito lang naman tayo sa 0 to 1, tapos yung psi from negative a to a. Okay, so ito yung kailangan nating isolve. Equation. So we want to find, na-stuck yata yung screen ko, pero yeah. We want to find f such that this equation is true. Ang malaking problema, paano natin matatanggal si f mula dun sa integral operator? Alright? And I don't think we were taught paano mag-solve ng integral equations. So 151, natuto kayo how to solve differential equations, right? Kaya lang ito ay isang integral equation. integrals naman yung involved doon sa process. So, paano natin mahanap si function f? Unang-una, malaking problema to kasi function f yung hinahanap natin. Tapos nasa loob pa siya ng integral. At hindi lamang siya nasa loob ng integral. Meron pang nakamultiply sa kanya na komplikadong function psi. So question is, how do we solve for f in this integral equation? Symbolically, that's a big problem. Mahirap usually mag-solve ng integral equations. There's a whole graduate level theory of integral equations na hindi natin dinidiscuss sa undergrad. Pero dahil wala tayong techniques para doon, ang gagawin natin next meeting, titingnan natin paano ko to ma-approximate by an easier model. Oops. And then for that, I'll take advantage of the fact that the convolution operator A ay linear in nature. Dahil linear yung ating convolution operator, ibig sabihin, kaya ko siyang i-represent by a linear equation. I can replace this continuous problem or this integral equation by a discrete model or by a linear equation. Right? So, itong operatorial equation na to, tinatawag ko siyang operatorial equation kasi isa siyang equation na involve yung operator. In particular, it's an integral equation kasi yung operator natin ay integral in nature. This is a continuous problem kasi integral equation siya. Hindi ka nag-work on a discrete data, naghahanap ka ng isang function. At sabi ko nga, mahirap i-solve yan. Ang gagawin natin, dahil linear operator naman yung convolution, ipoprove nyo yun sa problem set. Ngayon, kaya ko dapat siyang isulat as a linear system. Kaya ko siyang i-approximate by a linear system, and that's what we'll do on hindi na pala. Pa-weekend na pala, no? That's what we'll do on Tuesday. All right? Sa Tuesday, makikita niyo yung siguro unang best niyo makikita paano nag-discretize ng isang continuous problem. And if you will be doing your special problem with me or your thesis with me, usually ganun yung gagawin natin. Hanap tayo ng isang continuous model. Yung forward operator na pipiliin natin ay dapat linear, no? Or marirestrict tayo sa phenomenon na merong linear operator. Tapos ang gagawin natin, nagsosolve kayo ng function, pero hindi natin yung gagawin mano-mano. Gagamit tayo ng numerical techniques on how to solve that operatorial equation, and that could be done by discretization. And that would be our topic on Tuesday. All right? So makita nyo doon, gagawin ko siyang isang linear function. So instead na ang data ay si function g, all right? Kasi di ba kanina, AF equals G, si G yung data, which is the convolution, ito yung makukuha mong data. Pero sa totoong buhay, wala ka namang continuous function na makukuha na data. Ang makukuha mong data ay discrete measurements. Halimbawa, kay 0, may makukuha ang function value. Kay 0.01, meron ka uling makukuha ang isang value. Kay 0.02, may makukuha ka uling isang value. Yun yung nakukuha mong measurement sa totoong buhay. Hindi mo nakukuha yung actual function kasi hindi ka pwedeng mag-measure continuously. You can only measure in discrete intervals or discrete increments. So instead of the whole graph, ang data lang natin na makukuha ay yung mga blue dots. Tapos from those blue dots, gusto nating ma-reconstruct ano yung function f. Represented again by a bunch of points or a bunch of function values f of x. And that's what we'll do on Tuesday. All right? Okay, so I think we can stop here. Medyo may mga babaguhin pa ako dun sa modules, so kindly watch out for it. I'll announce when it is ready. Yung mga minor things that I mentioned earlier, yung mga adjustments dun sa definition na sinabi ko kanina, I'll just put it in writing para meron kayong final copy na maayos na. All right? So, but any questions so far? Or kailangang i-digest? But I hope that for this session, medyo naging familiar kayo dun sa convolution operator. Okay? At least the computation of the convolution operator. And the specific convolution operator that we will work on next time. All right? Any questions? Wala naman? So if there are no questions, then thank you guys for joining me today. Enjoy the weekends, and let's see each other again on Tuesday. All right? Bye, guys.
Thank you po, sir.